Thank you very much for having me here. Thanks for the introduction, Sean. Yeah, I'll tell you a little bit about myself. I'd like to start sharing the screen with my PowerPoint presentation. But firstly, I would like to applaud you all for being at the forefront of knowledge creation about our own universe, which is a field that I admire. This presentation is called The Art of Physics, not as a metaphor, but as an exposition. There is art to be found in physics, and I'll try to convince you of that by the end of this presentation if you're not already convinced. I came to Canada in a very cold day of February 2004, and I've learned English by reading the explanation of the astronomy picture of the day from NASA and by watching The Elegant Universe of Dr. Brian Greene on PBS. I wasn't totally new to the field. Of course, as a child, I watched TV shows about astronomy, and those ones captivated me immensely. Then as a teenager, who didn't I love the science fiction genre? I even wrote some short novels. In Calgary, from 2006 till 2019, I've attended almost all the open house events at the Rotney Astronomical Observatory, and I organized trips with friends of mine to these events. And I'm also a friend of the Dominion Astrophysical Observatory in Penticton. This is I in 2011, June 27th. You could perhaps find my note in the guest book, having fun around the telescopes. And I'm telling you this because I'd like to know that what I'm about to present to you in the next minutes is a direct effect of your scientific public outreach. So good for you. The seed got spread very well. To get things started, here is a short video of mine called Redshift Navigator. It's the name of one of my works, which touches on the theory of the expansion of the universe. I'll let it run for a minute, then I'll get back to you later in my presentation. All right, did you notice the symmetry of the Big Bang? Right there, I'll tell you about it. Not long ago, I had a conversation with a scientist, let's call him Brian, who asked me what qualities one must possess, in my view as an artist, to be a scientist, to which I responded, honesty and creativity, for it takes raw honesty to admit changes against ideas acquired during our lifetimes, against the archetypes. And for pure creativity is what is needed at the end of knowledge, beyond which no one else has stepped forward before. You see, scientists are true artists, in my opinion. I see no difference between the creative process required when in front of a blank piece of paper or in front of a blank canvas. Both actors must leave the paradigm behind in order to be able to pronounce new expressions. But my friend pointed me to another virtue of a scientist, which is the courage. That thing you need when you have to present a new idea to the world. And that made me think of Boltzmann and made me think of Van Gogh. I guess Brian was right. I'm sure you have your own stories, and I'd love to listen to them. Today, I'm talking about my art. I'm a professional artist, and I'm also a mechanical engineer. And for many people, the two domains cannot be more antagonistic. One is practical by its nature, and the other one is anything but practical by definition. Somehow they work together just fine for me. My art evolved from the craft of stained glass, a medieval art with spiritual lecturing capacity in the Gothic tradition, and later with a decorative role in the secular Art Nouveau of the last century. What I kept from it is the technique and the material, the lead and the glass, but I departed from it in terms of spatiality, architectural designation, composition, and most importantly, the narrative. The narrative is what brings me in front of you today, declaring that physics makes great art. And I can only hope that by the end of this presentation, you'll agree with the statement. This is the set of artworks I want to present to you, and I'm going to try to build the argument for arts from physics, holding the view that the universe is coherent, thus deterministic and unique, and possibly without a beginning or an edge. I don't intend nor I need to defend this view. I only want to point out that the works you're about to see try to remain consistent in following the same underlying philosophy. There is a follow the science commitment in my approach, which is a difficult choice. I've studied peer-review paper writing just to understand the exigencies. But this is not common for an artist, to curb your imagination to what one can respectably derive from theories. Nobody asks for that. Artists want no boundaries. Yet this is an important aspect of my approach. I'm basically taking a scientific stance in an artistic production, more or less rigorous, of course, to try to see if any art comes out of it. And let's see if the method works. You'll be the judges. But before we go into the works, I would like to confess another dimension of my work. Listening to the public lectures of scientists and philosophers like Neil Turok and David Albert, I've gathered that the controversies over the standard model of quantum mechanics might be rooted into the inadequacy of the language. Observer and vicinity seem to be good examples. And since geometry shows up everywhere in physics, in notions like symmetry, waves, fabric of space-time, spin, etc., concepts that are instrumental in my compositions, I began thinking of them as stories written in the language of geometry. Plato thought that oral communication is superior to writing communication. On the same thought, maybe visual communication is superior to verbal communication. So that's a little bit about how I'm approaching physics in my artistic studio. Admittedly, this wouldn't be possible without the Dada movement, which allows the artist to observe the world beyond the observable. The movement also gave rise, among others, to conceptualism, which seems to be the artistic domain where people place my work. I said observing and not representing because that's where any investigation starts, even for artists, that should be true. But for you, the scientists, observation means data. And half-jokingly, I would say that you are already in an art movement called data. Your theories are your work of art. The first work I want to show you is called Space Matters. I've completed it in December 2015, right about when rumors about the first discovery of the gravitational waves at LIGO came out and to be announced officially in 2016. The work presents the fabric of space-time in a dual-layered material with yarns waving along its axis in reference to the gravitational waves. As you can imagine, I was jubilating because months earlier when I started the project, the concept of gravity waves was an untested derivative of the century-old theory of Einstein. To my satisfaction, in early 2016, I've got the chance to exhibit it at the Rodney Astronomical Observatory in Alberta during one of the open house events organized by Dr. Phil Langeau. And this is a short video of it.
You might be wondering about this fabulous, glitzy-looking piece of artwork here. The artist is here, Catalan. He probably holds the record for the longest stretch of open houses anybody's ever come to, ever. And he's a real fan of what we do here. And he's an artist, and he has a very, very fantastic piece here that's got cosmology and science and particle physics and art and everything in it. And he would love to tell you more about it. So he's up here at the front if you have any questions about his artwork. Maybe you want to try to do it stained glass yourself or something like that.
Yeah, Space Matter talks about the foundation of reality, which is to be found in the laws of physics. It talks about the fabric of space-time, about subatomic particles, about the energy of the vacuum, the superposition, the constancy of the speed of light, about dark matter and dark energy. It talks about many layers of emergence, from physics to chemistry to biology to psychology to sociology, including abstract thinking and humor. Perhaps it would be fair to say that the world must be deterministic, I thought. But what a severe pronunciation this is. I knew the right person to ask about it. French polymath Pierre-Simon Laplace. Laplace's demon came about in my studio, talking about determinism, randomness, and free will. Central to the work, one can see a sequence of arching objects, this one, evolving from no regularity to geometrically rigorous shapes. That is a temporal succession of stances taken by virtual particles popping out into existence from the energy of the empty space. The succession of the stances reflects also on what duration means and brings up the quantum nature of the subatomic world. I have another very short video of a light painting just to allow seeing the texture of this work. The background is made out of opaque glass, all black, as it would be in the Planckian domain. At the top of the arch, there is something like a transparent dome that resembles a roulette, the symbol of randomness. On the right side of the arch, there is a silhouette. It's hard to distinguish here. It's like an athlete, a human body stretching out. This is the arm up. This is another arm down. This is one of the legs, another leg here. This is the head looking up. This silhouette is the demon itself, is the vast intelligence touching the roulette, stopping it or maybe spinning it, because no one knows exactly how this works. And my intention here is not to give an answer to the question of determinism, but to present the problem to the public for discussions. Of course, there is more to the symbolism of this work. The superposition, probability wave equation, emergence, and the fabric of space-time appear again. Now, since we began exploring the domain of the smaller scale, I thought I'd like to further investigate whether there is anything to be found beyond the Planck scale limit. And what did I find? I found this. This work is called baryonic, in reference to the baryonic matter. And its base is a black disk of fusing glass with colored strips running across random directions, depicting a probe under the microscope. But here is where I let my imagination loose and my hands free. The most powerful existing machinery and the most powerful mathematics cannot go where the imagination goes. And the beauty of it is that nobody can contradict me. This is humor in my studio. This is the back side of it. And again, a little video with the work turning around. Baryonic touches on the concepts of matter, subatomic particles, the Planckian scale again, and the limits of knowledge. When I present these works to the public, I take the time to explain in much more details, but now being in front of scientists, I don't feel the need. All these concepts are known to the audience. So next, after exploring the smallest things, the other end of the scale seemed necessary. The scale of the largest fascinates the scientists, the philosophers, and the theologians. That end must be found by investigating the very existence of the universe itself, I thought. And as I learned over the years, wonderies about the universe's inception, size, scope, and properties persist. The very idea of a forever existence or a forever extension is inconceivable for a normal human mind. But this is exactly what fascinates me as an artist about physics. Years ago, I saw a model of Laniakea, the supercluster, with the great attractor and the galaxies following the flow lines like a boat on oceanic currents. And I thought, wouldn't it be nice if you'd be able to navigate on those currents? I know there is no conceivable technology able to do that until now. I'm introducing you to my Redshift navigator. This work that looks like a sail ship harnesses not only the energy of the expansion of the universe, but its prime mover is tied into the Big Bang energy. One question that I often get when I show this work, why redshift and not blue shift? In what direction this sail moves? This is the back side of it. The Redshift navigator conveys the topics of dark energy, expansion of the universe, space travel, multiverse, redshift, shifting, blue shifting, Big Bang, brain collisions, or Janos point, as Julian Barbour presented. I'll let you watch for the second time that movie with this work rotating, and I'd like to point out the structural element. Evolving from the stained glass, this is one technological advancement I've done. I've separated the structural element from the aesthetic element. And in this case, you see the structure clearly defined and the aesthetics are occupying space. They don't have to be in a vertical plan anymore. That has nothing to do with science, just with maybe technology and engineering. Those wires and the bend rods are under tension. Being under tension gives them stability. I like the idea that there is fragility in this powerful structure. If you cut one of the wires, it may break apart. All these marvelous discoveries about the universe made by science hide yet another extraordinary secret that captures my interest, which is how come the universe, so constants that govern the laws of physics, are so well adjusted that otherwise matter, stars, galaxies, and life itself wouldn't exist. Where do they come from? My thinking took me to the idea of an underlying mechanism that makes it all possible. This new sculpture, starting with the orbital model of the atom, the Bohr's atomic model with nucleus surrounded by several orbits, but I stretched it down so it gets a volume of space, making it look a little bit like an amphitheater. Now, both horizontally and vertically, you have thresholds as suggestions for the quantized reality. Sometimes the electrons leave these orbits and they spiral out, leaving the atom. The phenomenon known as radiation. The two shoes, of course, are a reference to Schrödinger's cat, dead and alive at the same time. The metaphor doesn't end in the box. Schrödinger's metaphor extends to our everyday life. If the Copenhagen interpretation is correct, then we are dead and alive at the same time. There is also a flower near the center, suggesting that the macro-reality that we live in is made out of this utterly hard to decipher, hard to understand world of physics. All around the body of this work, you will see levers and gauges and scales and gears, suggesting the idea of this underlying mechanism making the world tick. And this would be the final work of mine that I wanted to present you today. In terms of future projects, I'm in conversation with program director at Cosmodrome Aerospace Museum in Laval for a possible collaboration in the future, an exposition, maybe a presentation again. And I have other works in my studio that are related to physics. Maxwell's Demon is another one. And I would like to take the opportunity to launch an invitation to those who might be interested in teaming up and participating to an art residency program at CERN. They organize such programs every 3 years. The program consists in 3 months residency at CERN, talking with scientists, visiting labs, and participating in conferences and building up an idea. Here is the link, and these are my contacts.
All right, thank you so much for the wonderful talk. Now, do we have some questions from the audience? Hi, Sid.
Okay,
Yeah.
can you hear me now?
Yeah.
Yeah, I found the works very fascinating, and especially, we have a good mathematical theory of what's going on with strong interactions and unification, but what actually is behind all this mathematics? And I thought your art somehow, tries to get at what's behind all the mathematical and physical theories. Found it very fascinating.
Yeah, as I said at the beginning, I'm trying to follow the mainstream scientific ideas. I know there are lots of controversies, and you can get lost into all kind of fantasies about how the universe works. But I want to stick to the basis. I want to stick to the theories, the realistic theories. Yet as an artist, I have the liberty to go everywhere I want. So maybe I'm stepping behind a little bit without knowing it. Maybe I'm getting there where you're saying it, but I don't know.
No, I think it was very fascinating to try to look behind what the theories present, and I'm sure it's speculative, but it's art.
Yeah.
I was also pleased that you had E equal pi I plus 1 equals 0, every mathematician's favorite formula.
Absolutely, yeah.
Brent.
Yeah, I'm curious if you've thought at all about the interaction between science and engineering, and that fundamental science enables engineering advancements, and engineering advancements enable science. Look at the James Webb Space Telescope, for example. There's fantastic images and science coming out of it that will come out of it. But all of that happens because of the toil of probably thousands of engineers over many years.
Yeah, I know the practicality, the practical mind of the engineers is also something amazing. The theorists are building up something abstract, and then you need someone to connect that theory to the reality and make it work. And often we see the possibility, something that for certain people seem inconceivable, others find ways of doing it. The Bell's inequality theorem, I think, is one of them. He showed us how one could possibly test theory. I find it amazing.
Are you familiar with the mathematical sculptor Hallam Ferguson?
Not much.
Yeah, he does a lot of stone sculptures that are based on various mathematical formulas and ideas. There's a famous sculpture at the Berkeley Math Institute that's one of his. It's called the Klein surface or Klein manifold, and it tries to illustrate some very abstract algebraic geometry in a physical way, and he's done a lot of sculptures based on mathematical concepts.
Yeah, I'll be curious to explore that.
Yeah, it's Ferguson. If you just Google him, Hallam Ferguson, he's got a website, and I think he was a professor at Brigham Young University, a math professor, but also he had a background as a sculptor, and he's done a lot of work on that. It's sort of like an extension of what Escher did in some of his drawings, where he took different ways of tiling the hyperbolic plane and turned it into art. And Ferguson is more or less a three-dimensional extension of the kind of thing that Escher did. Anyway, it's worth tracking him down.
Certainly, I'm curious of that, and my curiosity comes from the question whether or not such works of art may help the imagination process, the thinking process. Because you scientists, you are bound to follow the data, and it's difficult to present new ideas. But we artists are not bound to that idea. Where does this take us? It could take us in wrong places, of course, but it could also, I don't know, maybe offer some ideas, some suggestions, some ways of looking at things.
Yeah, absolutely.
Any more questions from the audience? All right. Well, let's thank Kathleen for the wonderful presentation. It's very beautiful, unique combination of art and some physics and science. And thanks everyone for coming, as always. I'll send around the link, Kathleen, later, the recording of the talk. And I'll see you guys next time. All right.
Bye.
Have a good afternoon, everyone.
Thank you very much.